Okay, so this example we're going to look at to find the zeros of a polynomial function. And the question says, state the number of possible real zeros and turning points. And we're given a function. And the function in the question is f of x is x cubed minus 5x squared plus 6x. So what do we know? So we're going to look at this and we can see that this has, looking at the leading coefficient and the highest degree, this is 3. So the maximum, or the number of roots that we're going to have, so the number of roots is going to be 3, the same as the leading degree. Now the turning points, we know this is n minus 1. So if the leading degree is 3, we're going to minus 1, so this is going to be 2. So this is the maximum number. It is possible to have less, but you cannot have more. So let's have a look at the equation. We have, the function that we have. So we need to factor. So we're looking for all the factors. So the first thing we can do is find the greatest common factor, which is going to be x. So we're going to factor by x. So if we do this, we'll have x squared minus 5x plus 6. And now we can find the factors of this term here. So factors of 6, they're going to add to make minus 5. So this is going to be minus 2 and minus 3. So x minus 2 and x minus 3. So these are all the factors. So to find the zeros, we need to make everything equal to 0. So x equals 0, x minus 2 is 0, and x minus 3 is 0. So we'll have a 0 at 0, and this will be x is equal to, so that's x is equal to 0, x is equal to 2, and x is equal to 3. Now if we were to check, so we could use Desmos or a graphing calculator. Our graph will look something. So I'll see if I can draw this. So our graph is going to go through, it's not very straight, so I'm going to do that again. So here's our points here. So we said the zeros. So our graph is going to go, it's going to come down through here, and then it's going to go up, and it's going to come down through the 0. So this is the 0. So we've got a point here at, this is going to be 2, and this point here is going to be 3. Okay, so you need to try this question. So you can pause the video, and then when you're ready for the answer, you can press play. So I'm going to explain. So the first thing we're going to do is factor by x. So that'll leave us with x squared minus 6x minus 27. And then we're looking for the common factors. So 27, so we have minus 27, and we have 9 and 3, and we need it to equal minus 6. So it'll be minus 9 plus 3. So x minus 9 and x plus 3. So we have so it's an x to the power 3, so we know this is going to be 3 roots, and the turning point will be 2. Now the roots, we've got a root at, so we're going to make this equal to 0, so x is equal to 0, x minus 9 is 0, and x plus 3 is 0. So this is going to be x is at 0, x is at 9, and x is at minus 3. Okay, so here's another question for you to try. So just pause the video and answer the question, and when you're ready for the answer, you can press play. Okay, so I'm going to explain how to do this one. So we've got x to the 4, so we're going to write this, so I can write it as x squared to the power 2 minus 8 and x squared plus 15. So I'm going to use the quadratic form. So this is where I have au squared plus bu plus c. So I'm going to replace, I'm going to say let x squared equal u, and I'm going to replace, so I'm going to say I've got u squared minus 8u plus 15, and now I can solve this equation, so factor. So factor in, so I'm looking for factors of 15 that will for minus 8. So we've got 5 and a 3. They need to be negative to give a positive answer, so they're both going to be minus. So we're going to write u minus 5 and u minus 3 will be equal to 0. So now I'm going to replace. So I'm going to say let, so u equal x squared. So I'm going to replace it back. So we're going to say x squared minus 5 equals 0. And I'm going to say x squared minus 3 equals 0. So this is x squared is equal to 5. So if I take the square root of 5, this is going to be a plus or minus answer. Or I've got x squared is equal to 3. So again, I'm going to take the root of 3. So I'll have my answers. Now, because this was a quadratic, power 4, the number of roots is 4, and we have roots at plus or minus root 5, and we have roots at plus or minus root 3. So there's our 4 roots, and we have our turning points. So we'll have a maximum of 4 minus 1 of 3.